Hello girls, so this is the revision on 3D shapes. Again, I have chosen some questions from ME and some challenging questions in this revision, so let's start. So this is the question from ME Test 1, question 18. It asks you to find out which nest can be folded into a cuboid. So when you are going to solve these kinds of problem, you can look at the adjacent sides. Is it the adjacent sides are equal in length? Can they be attached? So let's take A as an example. So maybe we choose two adjacent sides like this one, and its adjacent side is this side. Are they equal in length? Can they be attached? No. So A cannot be folded into a cuboid. And let's see B. So again, we choose one pair of adjacent sides, this one and this one. Can they be attached? No, they are different in length. And similarly for C, I can randomly choose the adjacent sides. Again, this one cannot be attached, so C cannot be folded up into a cuboid. And then we look at D, so you can check. So let's say this one, yes. Maybe another one, another pair, yes. Then after checking all, you will find that D will be the correct answer. It can be folded into a cuboid. This one is from question 19. You have to draw on the following square paper a net of cuboid on the right. Actually, I showed you the answer. Of course, you have other reasonable answer. You can have your own answer. But I just want to remind you that to solve this kind of question, when you're double checking your answer, you have to count the number of faces. So for a cuboid, there are 6 faces. So 1, 2, 3, 4, 5, 6. Right? And you have to also check the dimension of the faces. So one faces will be 2 cm by 2 cm. So you can see that 2 cm by 2 cm. Another face will be 2 cm by 4 cm. So we have 2 cm by 4 cm. Okay, 1, 2. And at the back, there's another 2. So you should have 4. Okay, 1, 2, 3, 4 faces with dimensions 2 cm by 4 cm. And the remaining 2 will be 2 cm by 2 cm. And then you have to think about the orientation. Okay, how do you arrange these faces? So I hope when you notice these 2 points, the number of faces, the dimension of faces, and also think about its orientation, it can help you to solve this kind of problem. And the next one is a challenging question. So let's look at the question. It said that Richard used sticks and plastic balls to make the framework of a 3D shape as shown on the right. If he wants to change the framework into a hexagonal pyramid, so how many sticks and plastic balls should he remove? So first of all, the figure on the right is a, what is it? It is a hexagonal prism. Hexagonal prism. So you have to think about the number of sticks and plastic balls in the hexagonal prism first. You can count it one by one from the figure. This is method 1. Or you can note the relation between the number of base size sticks and the balls. I have make a table here. Okay. So under the column of prism, this part, this is the relation between the number of sides of the base the sticks and the plastic balls. So for example, in this case, it is a hexagonal prism. So we have 6 sides in the base shape, 6. So for the number of sticks, it will be 3n. 3 times n, it will be 18. And then for the number of plastic balls, it will be 2n. So it will be 2 times 6, so it will be 12. So you can also figure out the number of sticks and plastic balls in the hexagonal prism. And then, what about hexagonal pyramid? Using another relation, okay, between number of size of base, sticks, and plastic balls in pyramid. Similarly, you can find the number of sticks in hexagonal pyramid. So, number of sides of the base is 6, and for the sticks, it is 2n, so 2 times 6 it is 12. And for the plastic balls, it is n plus 1, so that means 6 plus 1, so there is 7. There are 7 plastic balls in hexagonal pyramid. Then you can compare, okay? So for number of sticks, originally in hexagonal prism we need 18. For hexagonal pyramid we only need 12. So 18 and 12. So that means we have to remove 6 sticks. For plastic balls, originally we need 12 to make hexagonal prism. And for hexagonal pyramid, we only need 7 plastic balls. So that means we have to remove 5 plastic balls. So method 1, you can just count on the picture to help you to find the number of sticks of plastic, or you can use method 2. Okay, look at the relations. You can also count the number of sticks and plastic balls and then do the comparison. So for this challenging question, it said that Frankie has 3 sticks P, and then 5 stick Q, and 4 plastic balls. If he wants to make a prism with equilateral triangles as the basis, so that means he needs to make a triangular prism, how many more of each type of materials will be needed at least? So for stick P, that is the longer one, we have 3. For stick Q, we have 5. And then for the plastic ball, we have 4. As there are more than one combination, so I make use of a table to do the comparison. And I list out the 3 items, stick P, stick Q, and plastic balls. So let's think about the first case. The first case, if I make use of the stick Q as the basis, stick Q. So the shorter one, stick Q, the pink one as the base. So I need 6 stick Q. And I need another 3 stick P for the vertical one. So for the number of plastic balls, there are 6. So this is case 1. And then for case 2, if the bases, the triangles, makes use of stick P, the longer one. So my triangular prism will be like this. And then the 3 vertical one should be shorter. Let me draw a shorter one. So for Q, like this is case 2. And again, I need 6 plastic balls. And also I can make use of 9, that means all stake P's to make the triangular prism. So stake P to make the triangular prism. That is case 3. And the last one, I make use of all stake Q to make the triangular prism. So this one will be smaller because Q is shorter. So this is case 4. Okay, then we can do the comparison. So for case 1, originally we have 3 stake P, so we don't need to add any stake P. And then for Q, I need to add 1 more Q, and for the ball, I need to add 2. Okay, and then for case 2, I need to add 3 more P, and then no for Q, and then 2 for plastic balls. And then for case 3, I need to add 6 P, no Q, and 2. Actually, you can see the answer now, but I still do the case 4 for you. So for case 4, for P, we don't need to add any more P, and then we need to add 4 Q, and then 2 plastic balls. So you can see at least we need to add 0 stake P, 1 stake Q, and 2 plastic ball. That is answer A. So sometimes you need to make table if there are more than one combination. Okay. And the next one. Choose the 3D shape in which the number of edges is 2 times the number of sides of the base. So this one, again, you need to think about the relations between the number of base sides and the edges. So I have shown you this table before in the previous questions. So you are comparing the two items, which are the number of edges and the number of sides of the base. Okay, so that means you are looking at this item. So only in pyramid, the relation is 2 times. You can see number of base of the size is n here, and the stakes is 2, or edges, we say edges is 2n. So you look at the multiple choices, only A is a pyramid, all the others are prism. So A will be the answer. Or of course you can count it one by one. It is also another way to solve the problem. So this one, Ken has the foreign stakes and plastic balls. Can he use these materials to make a hexagonal prism, and why? So you can count the number of balls and stakes in the picture, or again you can make use of the relation. This time the relation is in a prism. Okay, and the number of sides of the base with 6. So this is 6. So how many stakes do we need? We need 3 times 6, that means 18 stakes. How many balls do we need? 2n, that means 2 times 6. So we need 12. So originally, how many stakes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 stakes. How many balls are there first? 3 times 4, so that is 12. So you can get the answer. The hexagonal prism has 12 vertices and 18 edges. So if we want to make the hexagonal prism, we need to add 6 more stakes. So you have to count clearly the number of the vertices and edges in the hexagonal prism first, and then tell the number of stakes we need to add. Okay? So I hope that you can learn more in the 3D shapes. Thank you.